Hello, geometry. Here we go with lesson 2. I kind of referenced this at the end of lesson 1 that I'm going to give you some shortcuts. Usually people like shortcuts. So you're not going to know what SSS and SAS mean right now, but we're going to start to prove two triangles are congruent formally. The last lesson, it was sort of formal, but it was more just showing you that all 6 parts had to be congruent. So kind of just reference the first answer there. How many parts have to be congruent in a triangle before we can say the triangles are congruent? 6, right? Now, I'm going to tell you that we have 5 shortcuts that allow us to prove triangles are congruent. Each shortcut requires only half, only 3 parts to be congruent instead of 6. However, it does matter the order in which those parts occur. All right, so you can't just pick any 3 parts and say, oh, these 2 triangles are congruent because there's 3 parts. Doesn't work that way. All right. So what 3 things could I use? Well, the first one is SSS postulate, and all those S's stand for side. So side, side, side postulate. And what that says is if 3 sides of one triangle are congruent to the 3 sides of another triangle, then the triangles are congruent. All right. So there's your example. All I've got is the sides marked. I have nothing with the angles. Last lesson, that would be bad because we couldn't say anything. But with this postulate, we can actually go in and say that these 2 triangles are congruent. So let's go ahead and give the triangle congruent statement. So I'm going to say triangle ARN is congruent to triangle. Well, now this is a little tricky here. I went A to R, right? So I covered the side that has a single marking. So I have a single marking here. So it's going to go either H to Z or Z to H. Now, does it matter? Yes, it does. So let's look at the next step from R to N. So I went 1, the side that's marked with 1 to the side that's marked with 2. So the side that's marked with 2 is here. So that should help me start with H goes to Z, and then Z goes to P. Okay. That's probably the hardest part with side, side, side. We have all 3 sides. Naming the triangles can be a little trickier than with angles. Angles are a little easier to see. At least most people think that way. All right. The next postulate is side angle side postulate. If 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of another triangle, then the triangles are congruent. Now, that idea of an included angle takes some people some time to get used to. Now, we're going to do a couple practices here on naming that included angle. So what is the included angle in each set of triangles here? Well, A is just a single triangle. So you see how there's 2 sides marked. The included angle is the angle that's between those 2 sides. So if I draw those 2 sides, which angle gets marked? H. So angle H is my included angle. Okay. B is a lot trickier to see because I've only got one side marked. Can I do anything with FL and GK? Not right now. Could I do something though with FK and itself, right? Isn't that the reflexive property which says those 2 are congruent? So now if I follow those 2 sides that are marked, well, that's itself. And then I'm going to follow this one and follow this one. I get 2 angles. I get this one and I get this one. And then I'm going to name those. So angle GFK and angle. I'm not going to say they're congruent yet. They are, but right now I'm just wanting to look at what are the included angles. So those right there are the included angles. All right. before I move to the back, you can't say this angle and this angle are congruent. Well, you could say they're congruent, but that's not going to help you, right? Because you're going to have two sides and then the unincluded angle. Well, that doesn't fit the postulate. Okay, so if we were going to try and prove that those two triangles are congruent, I would have to show that these two angles here are congruent, not these two. Okay, let's go to the back. Can we conclude that the triangles are congruent? If so, give the congruent statement and justify. If not, tell what other information you need to prove them congruent. So this first one, can we prove those two triangles are congruent? Well, what's marked? I've got two sides and an angle. Is that angle the included angle? It is not. So I cannot prove that these are congruent. So if yes, well, they're not, so I can't do this. If no, what other information would I need? Well, I can do two different things. If I knew that angle, and we gotta look at the included angle, which is angle T, were congruent to angle V. If those two things were congruent, then the triangles would be congruent. What else? Or, or, it doesn't have to be both, it just has to be one of these. Or if I could prove that RS were congruent to WU. What would that do? Well, then that would give me side, 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 right? 1, 2, 3, 1, 2, 3. If I knew that, then I could say those two triangles are congruent by side, side, side. Next one. Can we conclude that these are congruent? Well, I have two sides marked. So it's either got to be the included angle or the third side. So what's the third side? That's MK. Isn't that congruent to itself? Yes, it is. Okay, so I know that those two triangles are congruent. Why? Well, let's do first of all, let's do the congruent statement. Triangle, and I'll just do the triangle on top. So I'll do this one. LMK. Again, this is probably the hardest part. What matches up with L? That's usually pretty easy. That's J. But now which way do I go? L goes this way to M. That's what I did at the beginning. I could have gone LKM, but then that would switch what I do with the next one. So J, when I went from L to M, I went over the side marked with 1. So from J, I go over the side marked with 1. So JK M. Now the justification why those two triangles are congruent is side, side, side. Okay, so side, 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 side angle, side. The other shortcuts that I'm going to show you, those are the reasons. Okay. They were congruent, so I don't need to do that. Okay. Real quick, before I move on, just to make sure you guys are good on the included angle. Let's say I had these two triangles. The included angle between those two sides would be angle J and angle L. Just another example of that. I'm going to try and type this so I don't have to take so long. All right, so we want to prove that the two triangles are congruent. That's what we want to prove. Try and prove those are congruent. Well, at this point, we only need 3 parts. So let's get started. First thing, AC is congruent, and I'm just going to put equals because there's no congruent button on the keyboard. But just know that AC is congruent to EC. So when you're writing this, you might want to put a little thing there. Why? How do I know that those are congruent? It's given to me, right? So there's one. I need a second one. I need a third one, right? Second and third. Well, I see another given statement. Do you guys see how there's given on the picture? Right? Given on the picture, but there's also given in words. So I'm going to do that. I'm going to copy that given down in number 2. C is the midpoint of DB. That was given to me. Now, that's not saying anything's congruent. I need 3 parts, right? So I'm going to mark this. I've got 1 part here. I don't have a second part yet. Now, that will lead to something. If C is the midpoint of DB, what does that mean? Well, if C is the midpoint of DB, that means it cuts DB in half. If it cuts DB in half, then these two things are equal. I need to write that now. I need to type that now. DC is congruent to BC. How do I know that? Well, I used the idea that C is a midpoint. So what I did was I used the definition of midpoint to say that. So now what I have is I have my second congruent statement. I need another one. Now, I've done 2 sides. Is there anything on here that shows me that the third sides are equal? AD and BE. Well, I don't see anything. So I need the included angle if I'm going to do this. What's the included angle? Hopefully you see it. It is this angle here. Are those angles congruent? Yes, they are. How do I know that those are congruent? Well, they're vertical angles, right? So I'm just going to write angle. You could use the symbol there. ACD is congruent to angle ECB. That's the vertical angles theorem. Okay. And now what we have is we have 3 pieces congruent. Now that those 3 pieces are congruent, I can go in and I can say, oops, that triangle ACD and triangle ACD is congruent to triangle ECB. Why? Well, it's one of the 2 shortcuts we just did. Is it side, 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 or is it side, angle, side? Well, if you look back at the proof, side, another side, and an angle. So I've got 2 sides and an angle. So what I write? Side, angle, side. Okay. And we just proved those 2 triangles are congruent. All right. We'll go ahead and clear that. And that's it for this lesson. We're going to show you the other two of the other shortcuts on the next lesson.